How's it going, Algebra 1? It's Mr. Knight here, and if you were absent, this is the note sheet we're going to be utilizing in order to get you guys ready for your homework assignment that goes along with this, okay? So what we're going to do, we're going to do something called factoring. Factoring is a really useful skill when we get higher up into working with polynomials, specifically with this branch of mathematics called quadratics. And it's going to be critical to our ability to actually solve those quadratics. If you were in class with me earlier in this week, you saw that we tried to solve a quadratic with what we have at our disposal, with the tools we know and the knowledge, and we were unable to do so. That's where this is going to start kind of building up towards, okay? What I want to do first is I want to just kind of break into some review, okay? So we're going to simplify these three expressions right here, okay? So again, I can simplify these by doing the distributive property. I'll take this first term, this term out here, and I'm going to multiply it to each of these guys here. And then I use my product rule to help me simplify this. So a times 3a will give me 3a to the second power. A times 7 gives me a positive 7a. And that guy is simplified. And this expression here, this binomial I got, is the same thing. It's equal to this guy right here. Let's keep that in mind as we're working with factoring. Again, with this problem right here, we're going to distribute the negative 2m. So negative 2m times m squared, that gives me a negative 2m to the third power. Again, adding my exponents when I multiply. Negative 2m times 6m is negative 12m squared. And then negative 2m times negative 1 is a positive 2m. And once again, this is equal to this guy that we just distributed. And finally, let's end off with 5xy times x and 5xy times negative 2y. Well, 5xy times x is 5x squared y. And then 5xy times negative 2y is negative 10xy squared. All right. And really what factoring does is it kind of asks us, how do I go from here back to before I distributed? Okay, because that's kind of what we want to do. This is equal to this, so we should be able to have some method to go in the reverse direction, okay? And that's kind of what factoring is. Really, though, if you need a definition of it, factoring is the process of separating a polynomial back into a product. And once again, product means the result you get when you multiply. So this would be my product right here. These guys are technically multiplying, and we want to get it back into this form right here. Some of these polynomials can't be factored, and if polynomials can't be factored, we call them prime. All right. And there's several ways to factor polynomials. What we're going to do today is we're going to start off by using what we call the greatest common factor, or the GCF for short. Okay. So again, the greatest common factor is the greatest, the biggest number that is in common with two numbers, basically. So I guess we're just going to have to really see that looking at number 1. Okay. So we're going to try and factor this guy. Well, between these two terms right here, 3x and 12, what's a number that they have in common? Well, they have 3 in common. And now that I'm basically taking this 3 out of both of these, okay? So the opposite of multiplication is to divide. So I'm actually going to divide both of those terms by 3, and whatever I'm left with, my remainder is going to go inside there. So 3 divided by 3, or 3x divided by 3 is just x. 12 divided by 3 is a positive 4. And so this is our factored form of 3x plus 12. And what's a way you could do to check? Well, if I went ahead and I distributed this 3 to the x and the 4, I would end up getting 3x plus 12 back because they are equal to each other. All right. And so that's really the process of what's going on. I'm looking at what is the greatest thing that they have in common, and then I yank that out, and then I basically divide what I had by what I yanked out. Okay? Let's see it with number 3. What does 5x and 30y have in common? Well, they both have a 5 in common. That's the greatest factor that they have in common. So I'm going to write out my 5, and then I'm going to divide both of those terms by 5. So 5x divided by 5 is just going to be x, and 30y divided by 5 is a positive 6y. And there we go. I just write my remainder in parentheses, and I keep what my GCF is on the outside. Now, we're not just factoring numbers. Sometimes we can factor out variables. And so let's see an example of that. Let's look at number 6. Well, number 6, okay, I'm going to start off with my coefficients. So I have a 4 and a negative 24. Now I know that both of those numbers share 4 in common. So I'm going to write my 4. But I also need to look at their variables. Well, this one has a y squared. And this one also has a y to the first power. Well, since they both have a y in there, I can pull out a y out of that, okay? Y is the greatest thing, y to the first power is the greatest thing they have in common. So I pull out my 4y, and I'm left with my remainder. So 4y squared divided by 4y is going to give me just a positive y. And then negative 24y divided by 4y, well, the y's will cancel. And so negative 24 divided by 4 is just negative 6. And that would be my answer. All right. Not too bad. Not too bad. Okay, let's move on to something else. Let's look at something that's more on the back. Okay, something a little bit trickier. All right, like number 13 is a great example. All right, number 13. Let's see what these guys have in common. So this is 18 a squared bc to the second minus 48 abc to the third. I know it's kind of hard to see on the sheet. So we'll start with the coefficients. 18 and 48. What is a number that they have in common? Let's think. They have 2 in common. Is that the greatest? Well, I know they have 3. Oh, maybe 4. No, 4 doesn't go into 18. 6. Does 6 go into both of them? Oh, 6 does go into both of them. So 6 is going to end up being our greatest common factor for the coefficients. Okay, and then I have an a squared bc squared for this first term, and I also have an abc to the third here. Well, they all have an a in common, and we're going to take the lowest one for right now. So we have a. B they have in common, so I'm going to pull out a b. And they both have a c in common. The lowest one is c squared, and this one's c to the third, so the greatest common factor between them would be the c squared. So I'm going to pull that out as well. And now I'm going to write my remainder in parentheses. So I'm going to divide each of these terms what I pulled out. 18 divided by 6 is 3. And now we have a squared divided by a. So again, my quotient rule tells me to subtract those guys. So I get left with a to the first. B to the first divided by b to the first. That just cancels out to 1. And then c squared divided by c squared, again, just cancels out to 1. So we're left with 3a as our remainder. I move on to the next term. Again, I do negative 48 divided by 6. And if I do that, I should end up with negative 8. And then I have a to the first divided by a to the first. So the a's cancel. B divided by b, b's cancel. And then I have c to the third divided by c to the second. So I get left with c to the first, and that is my factored form using the GCF again. Okay, just pulling out what they have in common and then leaving what the remainder is inside. Okay, let's look at 15 real quick. So let's start with the coefficients. 15. Let's see, between 5 and 13. Well, those numbers actually are prime numbers, so they actually don't have anything in common other than 1 and themselves. Okay, what about the variables? Well, again, they're not sharing any variables in common. They have an x and a y, but they don't share that. So this guy is actually a prime polynomial right here. I can't factor this guy, so I'm just going to call it prime. Okay? And let's do one more example together, and we will finish this guy off. Let's do something like number 20. Okay. So number 20, I have I'll rewrite this guy because I know it's hard to see. I have 18x squared yz minus 24xz squared plus 36yz to the third. And so let's go through this. We'll start with the coefficient. What's the biggest number that 18, 24, and 36 have in common? 6. They certainly have 6 in common. Anything higher than that? I don't believe so. So I think we're just going to go with 6. And now, again, we're going to go through each variable. Now, again, here's a little trick. Let's see if they all have an x in common. X squared, x, no x. Okay, so they don't all share an x in common, so I'm not going to factor out an x. I'm just going to leave that. What about y? Do they all have a y in common? Y, no, and y. Okay, so I can't pull out a y. Z? Yeah, they all have z in common. Z to the first, z to the second, z to the third. Well, they all have at least a z in common, a z to the first. So I'm going to take the lowest exponent z out. Okay, and now let's see what we have left over. So I'm going to divide each of these terms by my 6z. 18 divided by 6 is 3. X squared yz divided by z, well, the x squared y is just going to stay. But z divided by z just turns into 1, so it gets canceled out. So now we can move on to the next term. Negative 24 divided by 6 is negative 4. X divided by this, x is just going to stay. But I got z squared divided by z to the first, which just gives me z to the first right there, excuse me. And now we have this guy, 36yz to the third divided by 6z. 36 divided by 6 is 6. My y is just going to stay put. And then z to the third divided by z to the first will give me z to the second power. And again, if you want to check to make sure if that's correct, you can multiply this out through distribution, and you should get back this original equation right here. So, for a recap, rules defining a GCF of a polynomial. Look at your coefficients first. It's kind of what we were doing every single time. We were looking to see, all right, what do our coefficients have in common? And we start there. Part 2, a variable must be in common to all terms to be GCF. And we saw that with number 20. I was looking at the x's and the y's, but it wasn't in common with all of the terms, so I couldn't factor out an x or a y. However, z was in common with all of them, so I was able to pull out a z. Now, if a variable, z, is common to all terms, take the one with the smallest exponent. So we had z to the first, z to the second, z to the third, and again, I followed that rule too. I pulled out a z to the first. That was the one with the lowest exponent, though they all had a z in common. And then finally, we divided all the terms by what our GCF was, what we factored out, to get our remainder in parentheses. This is Mr. Knight, signing off.